Solving inequalities. Here we have 4 examples of inequalities using these comparison symbols: less than, greater than, less than or equal to, and greater than or equal to. So since here we don't have the variable isolated, we don't know what the solution set for each of the inequalities is. So basically what we can do in this case is to solve an inequality the same way, using the same rules pretty much for solving equations. So applying the properties of inequality or the properties of equality. Whatever you do on one side has to be done on both sides, so to keep the balance. Example number 1 says that my variable is p. In this example, the variable is q. The next one, the variable is n, and that one, the variable is n. So to start with this one, what we have here is addition. So the inverse operation of addition is subtraction. So I'm going to subtract both sides 3. And then my inequality will be reduced to, since this one is a zero pair, so the inequality would be p is less than, and this result, -5 and -3 is -8. So to have a reference, let's suppose this is -8. You know, this is a number to the left of 0. In the second example, we have that this operation is subtraction, so the inverse operation of subtracting 6 is adding 6. But remember, you have to do it both sides. So again, this is a zero pair, so q is any number greater than 10. So for a reference, I'm going to select this point as 10. 10 is a number to the right of 0, so, and -8 is a number to the left of 0. Here, in this case, the operation is multiplication. The inverse operation of multiplication is division. And in this case, since I'm multiplying times 3, I have to divide both sides by 3. So this is not a zero pair, but 1. Since I'm dividing 3 into 3, so this is 1. So n is less than or equal to 9. And I'm going to choose this point to be 9, just as a reference. The last example suggests division by 3. So the inverse operation of dividing by 3 is multiplying by 3. So that way, remember to do it both sides. So that way this is again 1. n times 1, n, and then n is going to be greater than or equal to -12. In this case, I'm going to select this one to be -12. Obviously, you know, in this case, -8 is to the left of 0, 10 is to the right of 0, 9 is to the right of 0, and -12 is to the left of 0. So now, being congruent and having a consequence about how to write, how to draw those inequalities on the number line, I'm going to draw my solution set. In this case, since p is any number less than -8, I'm going to draw an open circle, since -8 is not included. So -8 is not included in the solution set. Since p is less than -8, my solution set is going to be graphed as an arrow pointing to the left of -8. So in interval notation, it'll start at -infinity and it'll finish at -8. And since -8 is not a solution, since this is an open circle, so parenthesis here. This one, q. Q is any number greater than 10. Since there we have greater than 10, the circle is open. And then, since this one says greater than goes to the right. So notice here that I'm using a different color So you can see the difference between the number line and the solution set. In this case, any solution is a number greater than 10. Again, here 10 is not included. So any solution can be a number to the right of 10. For example, 11, 12, 13, etc. In this case, m is less than or equal to 9. So 9 is going to be, in this case, included. Because here I have the possibility for the variable to be equal to 9. So since this one says less than or equal to 9, less than means any number less than 9. So numbers to the left of 9. And finally for this one, n is greater than or equal to. That equal to gives the possibility for this negative 12 to be included in the solution set. Besides, the inequality says n is any number greater than negative 12 or equal. So equal is included. So that's why this is a solid circle, the same as this example. Now, to finish these other three examples using the interval notation, I know that this one, q greater than 10, starts at 10, but 10 is not included. That's why I write a parenthesis here. And since it extends to positive infinity has no limits. So that suggests the idea of having a parenthesis here. Now this one starts at the left, very, very to the left. So that represents, or that is negative infinity, and then the boundary or the limit is 9. But in this case, 9 is included, since here we have a solid circle and the inequality says less than or equal to 9. And to finish with this one begins at negative 12, and negative 12 is included. So the limit, negative 12, is included. And this one extends till the positive infinity. That means it goes to the right indefinitely.